Namaskar from your Sanmitra, Sustainable Mitra, Hydrogen Wala. Friends, what do you think? Which type of green hydrogen plants are commercially viable? Big plants, small plants. You may tend to think that due to economies of scale, bigger hydrogen plants would be more commercially viable. But like many in Western world, you too have been caught off guard. India's commercially viable green hydrogen plants are in small hydrogen sector only, and that too without any policy support. Now think, if small nudges are provided to green hydrogen plants in smaller hydrogen category, what will happen? A, it will facilitate many investment decisions. B, it will pave a way commissioning of many green hydrogen plant in various sectors, and that will give us required operating experience, paving a way for big hydrogen. Objective of this knowledge snippet is to share some of the thoughts on how we can provide policy nudges to small green hydrogen plants. Please refer slide here giving inputs to make green hydrogen more palatable to small hydrogen consumers in various process industries such as glass, steel, pharma, chemicals, sorbitol, lab-grown diamonds, semiconductor chip making, and so more. Your friend Hydrogen Wala has been championing this space through solutioning and feasibility studies in small green hydrogen sectors. Suggestions are given on the account of live experience of working on such solutions. NHM recognizes two types of hydrogen, which is biohydrogen and electrolytic hydrogen. First, the biohydrogen, where the prime concern is heavy upfront capex. Capital expenditure associated with bio-GH2 facilities through technologies such as catalytic methane decomposition or effluent-based green hydrogen or RDF-based green hydrogen is significant. If a subsidy is provided ab initio, initial capex burden could be reduced and many such bio-GH2 installation could flourish. Smaller bio-GH2 capacities also reduce the supply chain risk. Issue with the electrolytic hydrogen is heavy electricity costing during the operations. How the same can be reduced is explained in the subsequent slide. Please refer slide here on landed cost of electricity. It includes various components such as contract demand charges, state transmission charges, state distribution charges, state distribution losses, state transmission losses, electricity duty. All these add to approximately 1.5 to 2 rupees depending on state to state. Moment electrical installation like electrolyzer is planned in situ to a process industry facility, contract demand charges comes into effect. Point to be noted, this new addition to electricity load has been non-existent earlier and is coming into force only due to larger energy transition efforts through green hydrogen for achieving India's net zero by 2070. At present, contract demand charges varies between rupees 200 per kVA per month to rupees 350 per kVA per month across various states. This adds to around 0.4 to 0.8 rupees per kilowatt hour depending on number of hours of electrolyzer operations. If waived partially or fully, can help small hydrogen consuming process industries to reduce cost of GST so produced. In landed cost of RE, state transmission and distribution losses and charges accounts for 0.8 to 1.3 rupees per kilowatt hours depending on voltage level it's connected and charges levied in different states. If waived partially or fully, can optimize landed cost of electricity and help process industries to reduce cost of green hydrogen so produced. If we understand electricity duty for the process industry consumers is ranging between half a rupees to 70 paisa per kilowatt hours. At present, it gets added to landed cost of RE, and hence, if waived, the same can optimize landed cost and the cost of green hydrogen ultimately. Alternatively, like Odisha state green hydrogen policy, which offers RE at very competitive around 3.5 rupees per kilowatt for green hydrogen and its derivative projects, a separate tariff category for green hydrogen consumers could be created to offer a special rate for green hydrogen or its derivative production, thereby incentivizing small hydrogen consumers. To sum up, prerequisite for big hydrogen is successful small hydrogen. BioGH2 based hydrogen is possible provided we have a good amount of capex subsidy to start with. Electrolytic hydrogen in the small hydrogen category could be possible through reduction in the landed cost of electricity that can be achieved by four means: by partially or fully waiving various components such as contract demand charges, state transmission charges, state distribution charges, and electricity duty.